Hi, welcome to the third presentation of our magnetism unit. Today we're going to be looking at the difference between temporary and ferromagnets. Let's just jump right into it. Let me get everything pulled up. Alright, so today your learning target is that you'll be able to explain the difference between a temporary magnet and permanent magnet. For notes purposes, your slotted notes will begin here at the type of magnets: ferromagnets, electromagnets. So a ferromagnet are magnets that are made from iron, nickel, cobalt, or mixtures. So this is what you're normally used to: a solid metal magnet that we use all the time, like on your refrigerator or some that you've seen in classrooms before. They're magnets, and they're made of metal already, and it has iron, nickel, or cobalt, or a mixture of all of them. And then you have the electromagnets, which they're formed from passing electricity through a solenoid, which is surrounding an iron core. So electromagnets is a piece of iron with electricity passing through it, and that electricity causes the domains to line up and become a temporary magnet, as long as electricity is passing through it. Permanent magnets, they keep their magnetism even after they're removed from the magnetic field. So if you got two magnets together and you remove them, you still have two different magnets. So you can stick them on the refrigerator, you can stick them to another piece of metal, or you can move them around and they'll still keep their magnetism. These, of course, as you know, permanent just last longer than temporary. So these magnets keep their magnetism. This is what we're used to. This is what you've played with you can buy from the dollar store or whatever. You can move these magnets around and they'll still stay. They'll keep their magnetism no matter what. Now, permanent magnets. Let me move myself again. Permanent magnets can be made from iron, cobalt, or nickel. And the permanent magnets, their magnetic domains automatically line up. All right, and because they line up, remember, all those domains are working together, so it creates a magnetic field around that magnet, and it keeps that magnetic field intact even when it's not being used. These can be heated, dropped, or placed in another strong magnetic field, and it will demagnetize it. Did you know that? You can take a magnet that's just permanent, and you can actually demagnetize it by doing some things to it. You have to heat it up, superheat it, or excuse me, have to put it in another strong magnetic field to demagnetize the domains. But it would have to be in a rare situation that happens. So temporary magnets are made from materials that are easily magnetized. Now, you remember those materials that are easily magnetized: iron, cobalt, nickel. They're not permanent magnets. They weren't made like natural magnets. These aren't the kinds that you stick on the refrigerator or use to hold something up. These are temporary. So like electromagnets, if you've never seen electromagnets before, or think about, maybe you've seen the junkyard where it has the big crane with the big large disc, and it goes over to a piece of pile of metal, and then it picks it up, and then it moves it over to another piece, and then it turns it off, and then the metal just drops. So what they're doing is they are magnetizing and demagnetizing that piece of iron core using electricity, which is like a button inside of that truck that they're using. They'll hit a button, and it'll magnetize that core and pick up metal items and move them to where they want to very easily. You can use a lot of electricity and a big piece of iron to increase the magnetism and make it really, really strong. Or you can use a small one with a little bit of electricity, and it will make something very soft, something very not as strong, which we can pick up like paper clips, nails, and things like that. So electromagnets, electricity passes through, creates a temporary magnet. They lose their magnetism easily because of those domains not lining up. We see magnetism in nature. As I said, in the previous video, that our Earth uses a magnetic force field around it, and it protects us from solar winds from the sun. The sun will give us a lot of charged particles headed toward us, and if we don't have that magnetic poles that creates a magnetic field around the Earth, it can be damaging to us. It can where we don't have any electricity, no ways of communication. Those charged particles, which we know as EMPs, electromagnetic pulse, would devastate the world as we know it. It would be totally different. But because of the Earth's magnetic sphere, the magnetic force field around the Earth, those particles never make it to Earth. As soon as they hit that magnetosphere, it goes around and it just keeps on going past us, and it protects us. Now, when that happens, we see this as the aurora borealis, or the northern lights. And also, just like in the north, they have it in the south as well, the aurora australis, the southern lights. So something to really cool to see. It may be worth a Google. All right, so to summarize this, so ferromagnets are the magnets that we're used to, the ones made out of metal. They're made of iron, nickel, cobalt, or it can be a mixture, like nails, steel, things like that are alloys that are mixed together of these elements. And ferromagnets, they hold their magnetism. They're permanent magnets. Unless you put them in a superheated environment or a strong magnetism environment to demagnetize them, such as magnetite. Temporary magnets are made from iron or core of iron. We make temporary magnets by passing electricity through it and making temporary magnets where we can control magnetism. We can turn it on, we can turn it off. These are used a lot in our everyday life. Like I mentioned, like if you know the doors to the school, the one that had the keypad on the outside of the door that the teachers use to scan their key and then unlock the door. Well, that's an electronic switch that controls a big electromagnet that's hooked to the door. And once the teacher swipes their card, the electromagnet is told, the switch tells the electromagnet, hey, turn off. So it turns it off and the door is able to come open. Now, if you ever tried to open a door without swiping that, it's almost impossible. That electromagnet is so strong, the bond is so tight that it won't let it go. But as soon as that card is swiped and the switch turns the electricity off, it just becomes two pieces of metal they're not magnetized with each other. So hopefully this helps. As always, if you have any questions, you can go back through the video, make sure you got the correct notes, and thank you so much.